We have learned over the course of this video series that a parabola will get inverted if the value of the x squared part of a quadratic function is negative, and that when a constant is added to a quadratic equation, the entire parabola will vertically shift to the value of the constant. And for this vertical shift of a parabola, the constant is added outside the quadratic equation. For example, x squared plus 1. In this video, I want to ask what would happen if we add a constant inside of the quadratic equation. This would mean that the quadratic equation could be something like x minus 1 the whole squared. Now try and approach this one just as we did with the other quadratic equations by sketching up a graph from the table of x and y values the equation would give us. And here is the table that stores the x and y values of the y equals x squared equation so that you can reference and find a pattern between the two equations. Okay, we will start off with a value of x, value of minus 2 for reasons we will discuss later. So if the x value is minus 2 and we substitute it into the equation, the y value would be minus 2 minus 1 to the whole squared. Minus 2 minus 1 would be minus 3, and minus 3 the whole square would be 9. Moving on, for the x value of minus 1, we would get a y value of minus 1 to the whole square, which would lead to minus 2 to the whole squared, and therefore 4. If we compare this functions table with the table of y equals x squared, we are starting to see a little bit of a pattern here. But let's do one more of these just to confirm this. When the x value is 0, we would get y equals 0 minus 1 to the whole squared. And this would be minus 1 to the whole squared and therefore 1. And following this route, we would get a y value of 0 for the x value of 1, a y value of 1 for the x value of 2, and a y value of 4 for the x value of 3. And finally, a y value of 9 for the x value of 4. And as you can see from the tables, in a normal y equals x squared function, the y value of 0 would be obtained from the x value of 0. However, in the y equals x minus 1 to the whole squared function, the y value of 0 would be obtained from the x value of 1. This means that the y value that would be obtained from y equals x minus 1 to the whole squared function is exactly the same as the y equals x value function, with the only difference being that for the case of x minus 1 to the whole squared function, the x value giving these same y values as would always be 1 unit bigger than the x value of the x squared function. This is why we choose to start off the table with minus 2, because if the values we use to start with is minus 3, we would get a y value of 16 because it's minus 3 minus 1 the whole squared, and we would have a hard time visualizing it because the graph would scale so much higher. And if we plot all the points for y equals x minus 1 the whole square function, we'll get a parabola of 1. Comparing this with a normal y equals x squared function in this way, we can see that the x minus 1 to the whole squared function shifts 1 unit to the right. This pretty much confirms our pattern, because for the x squared minus 1 the whole squared function, it takes x 1 unit bigger than the x value of the x squared function to get the same value of y. You might ask, what about the function x plus 1 to the whole square? Well, the same pattern follows, and the graph would shift to the left by 1 unit. Sorry. From this graph of that function, we can see that it would take an x value 1 unit smaller than the x value of the x squared function to get the same value of y. So if you add a constant inside the quadratic equation, if it is positive, it would shift to the left, and if it is negative, it would shift to the right. This is opposite of adding a constant outside the quadratic equation, where if it's positive, it would shift upwards, and if it's negative, it would shift downwards. So it would be helpful for you to distinguish between those two. So in conclusion, this video series, a negative x squared value would make a parabola inverted. Adding a constant outside this quadratic equation will shift the parabola vertically, and finally adding a constant inside the quadratic function will shift the parabola horizontally. And we're done.